Hi everyone. So, we're gonna do differentiation and we are going to lick it. So, we're gonna cover everything, how to differentiate, and your worries are over because now you have this video with you that you're watching right now and you don't need to fear about anything. So, just sit somewhere and watch this video. Of course, you need to listen carefully. You need to know what's happening. So, anyway, differentiation. Let me just write it on top. What is differentiation? Well, it's it's basically finding the derivative or finding the gradient of a curve at any point on the curve. And before I get to that, I want to show you one example just so that we know our basics. So here I'm going to draw a really simple function, just a straight line going up and 45 degrees on either axis to the x-axis and the y-axis. So yes, this function you should have already known by now is y is equal to x because 45 degrees. So let's actually write as f of x is equal to x because you will need to know this notation and you will need to use this more. I'm pretty sure you already do, but if you don't, then please, you're no longer in middle school. So now we're gonna look at the gradient of the curve. So the gradient of this curve is 1. We all know that y is equal to x. There's a 1 before x. Of course, we don't write that actually, but there's a 1. So the gradient is 1. So if we take any 2 points on the curve, you know how to find the gradient. Delta y over delta x. Change in y over the change in x. Learn this in middle school. So that's how you find the gradient of any straight line. Change in y over change in x. And you can take any 2 points on the line. Any 2. Doesn't really matter because the gradient is always going to be the same, which will not be true for curves. But that's how you find the gradient. So the gradient of this curve, suppose y is equal to x, is equal to 1. So change in y over change in x is equal to 1. If you go to any particular point on the curve and all the points are in one straight line, they follow the same gradient in a straight line curve. That's why straight line curves are easy and we start with these functions before we move on to the curves. Yes. So if we take an example of a curve now that we know how to find the derivatives of straight line curves, derivative is basically the gradient of the curve at any particular point, and which we found 1. So we've differentiated this curve actually. So this is the first function that you've differentiated. So wow, you've already done differentiation. So now we can just move on to a slightly more complicated example. Otherwise we won't learn anything really. This curve, let's just say it's touching 0 over here. So this curve, f of x, is equal to x squared. Right? Easy. We all know this curve. We all know it looks like this. If you don't, then this video is not for you. Please go back to middle school. So if we want to find the gradient, if you want to differentiate this curve, how can we do that? It's not a straight line. it's a curve. And what I mean by this is that you cannot differentiate this curve at all as a whole. But you can differentiate a curve at one single point on the curve. So the derivative of this curve, which we've calculated here as 1, is not going to be a constant 1 over here. It's actually going to be a variable. It's not going to be a constant because the derivative keeps changing. So how do we find a derivative here? Over here we don't need to draw a tangent, but if we just draw a tangent to this, tangents are basically, just drawing a line right at the particular point. Over here I just drew a line and it's 90 degrees to the normal at that point. So if I drew a tangent at this point, x is equal to 0, then I draw the normal and I draw the tangent 90 degrees. As you can see, the tangent has a gradient of 0. So the derivative, or if we differentiate this curve at the point 0, the answer would be 0, right? Because look at this tangent, it's just straight. So this is how we basically find gradients of curves visually with tangents. So you draw tangents at points. Because what's a curve? Well, if you look at a curve over here, the gradient is always changing. So at this point, it's like a very steep line. Here it's less steep. Here, if you draw a tangent, it's less steep. And here it's not steep at all. Like it's just 0. So the steepness is getting lower and lower. And as you move right, it goes higher and higher. So the gradient is always changing. The gradient is variable. So the gradient is not a constant. As in this, you don't even need to draw a tangent here. Just draw lines. It's just a simple straight line, constant gradient, easy to differentiate it. So we're going to just differentiate curves in differentiation. You never get asked to differentiate lines, okay? So how do we differentiate x squared? Well, now we're going to come to a different concept. So we're going to now find out how to do it without really doing it visually, because you'll have to draw a super accurate curve for that, and you'll have to then draw a accurate tangent, which will be really time consuming. So there's a quick way, theoretically and mathematically, to solve it. So I'm going to write the rule to differentiate any function dy over dx of x to the power of n being any power. And yes, if you want to differentiate something, the notation for this is dy over dx. Okay? Some people can also write it as f prime of x as another notation. So f of x, the derivative of f of x is f prime of x, but I prefer using dy over dx because actually what happened is two scientists invented calculus at the same time. Yes, stroke of luck, and they're scientists, so they want to claim their work all for themselves, and so they made a different notation, but we're going to use dy over dx, okay? So the rule is to differentiate x to the power of n, nx to the power of n minus 1 is what we use to differentiate it. So if you want to differentiate this, we have to perform this operation here, and this is called the power rule. Power rule, yes. That's really important. This is actually the building blocks of differentiation. The first formula you learn in differentiating is the power rule. So let's differentiate x squared through the power rule. So x squared, so f of x is equal to x squared. So dy over dx, derivative, the derivative, so differentiating the function, is nx to the power of n minus 1. So n, so in this case, n is equal to 2. So you bring the 2 down, as in nx, n minus 1 to minus 1, which is 1, 2 to the power of x minus 1, which 2 times x to the power of 1, which is basically 2x. So that's good news. We've found the derivative of x squared. We've done our first derivative for a curve. So yeah, finally. So if we take a curve here, let me just quickly sketch that curve again. Yes, not accurate, don't mind please, but this is accurate. This is totally accurate. So the curve at the point x equal to 0, okay, let's just say that it's touching the 0. Just ignore this part. So if we draw a tangent at x equal to 0, the derivative of that point is 2 times 0, because x is 0. 2 times 0 is 0. Differentiate 0 for substitute 0 for x, obviously, so 0. So 2 times 0 is 0, and the gradient of the tangent is actually 0. It's a flat line. And as you go higher, the gradient keeps increasing. So suppose negative 5 x value. So take it up, this is the point, draw a tangent, and the gradient of this is negative 10. Right? 2 times negative 5. So it's a steep, it's a line that's actually going, it has a negative gradient, so it's going left to right, downward slope. If we take plus 5 point, and the gradient is 10, positive gradient, right? So it's that easy. So we can differentiate any function like this, really. So x to the power of 5, I really don't know how to draw that, but you can draw it on any graphing software or anything, but you don't need to draw it to differentiate it. So differentiating this will give us 5x to the power of 4 according to the power rule. It's that easy actually. As you can see, x, the gradient is always dependent on the x value on these curves. That's why I've said that the gradient is variable. It's not a constant. So it depends on what the x value is, the gradient will be different, which is what we've discussed, because the tangents are very different at every point on the curve. The curves have variable gradients while straight lines have constant gradients. Okay, hope it's becoming clearer now. So now we've touched on the basics of differentiation using the power rule. This thing over here, this is really important. So let's move on now to a slightly more complicated function. So a more complicated example. So, and using the power rule, we can differentiate many other functions, like let's say let's give, for example, 2x to the power of 5. Okay, that's a very light marker. So 2x to the power of 5. Okay, let's differentiate that. So of course, according to the power rule, which is, again, I'm writing it here, you need to memorize that. 2x to the power of 5, 10x to the power of 4. So it's that easy. So even if there's a constant behind x, which is 2 over here, you just bring the value down, multiply it by 2, like that. And that's how we differentiate functions. But let's move on to functions like e to the x. We always like differentiating this function. You should know what e means, the Euler's number. If you don't, then please go and study about it. It's a really interesting number, how it came up and everything. Wow, it has a really good history. So e to the power of x. So differentiating this function should be very simple, because the derivative of e to the power of x is none other than e to the power of x. Yup, no power rule. This does not apply for this. It's just e to the power of x. So yeah, and that's just how. And why is this? This is because e is a really special number. You should already know how special it is. It's literally the epitome of maths. It's used everywhere in maths. So e to the power of x. It's a really important number. Shouldn't shy away from this. This number is a beauty, Euler's number. But e to the power of f of x, so e to the power of another function, will not, the derivative of this will not be e to the power of f of x. Let's just check that out. So e to the power of 3x, let's just say, let's differentiate e to the power of 3x. So to differentiate this, you'll use the formula d, the derivative of f of x, times e to the power of f of x. So this is the rule for differentiating e to the f of x functions. So e to the 3 of x, well, take the derivative of the function, e is raised to, so 3 of x. So the derivative is 3. So, and how do you know that? Because f of x is equal to 3x. So the derivative of this is 3. You already know it's a straight line. So derivative is 3. And you multiply that with e to the 3x. So the answer to this, so dy or dx of e to the 3x will be 3e to the 3x. So now we can differentiate e to the f of x functions as well. Wow, that's cool. So we're still not done though, because we want to learn more. We love math, calculus for life, because we just need to learn more. So let's start with the differentiation of ln x. Ln x, natural log of x. Now again, if you don't know what that is, learn it and come back. Please, these are all prerequisites. So ln x, so if you want to differentiate a function, natural log of f of x, we'll do it to the following formula. Derivative of f of x divided by f of x. Or if you want to use it in the unwanted notation, f prime of x over f of x, which is in this case much shorter. So the derivative of the function divided by the function, right? Yeah, pretty straightforward actually. So ln 2x, let's differentiate this. So differentiating this, derivative of 2x is 2 divided by the function, which is 2x, is equal to 1 over x. Yeah, it's pretty easy. So dy over dx of ln 2x cubed, let's say, should give us the derivative of 2x cubed, and that is 6x to the power of 2, 6x squared, divided by 2x cubed. Simplifying this will give us 3x over x squared. But still not simplified, so this would be 3 over x. So the derivative of ln 2x cubed should give us 3 over x. So let's just recap what we've learned to differentiate. So now at this point you should not be failing in calculus because you've learned the fundamentals now. Now you just need to apply these concepts in different questions, which will only make you good with practice. So now do those questions in your math book. Go ahead, just do as many as you can, and you'll just get better. So we've learned how to differentiate e to the x. We've learned how to differentiate ln x. We've learned how to differentiate x raised to any function multiplied by any constant, etc. And oh, small note, if you want to differentiate a function 2x to the power of n plus, suppose 4x to the power of n. So if we're adding two functions, so this is a function here, and we differentiate this whole function, then that's easy too, because we just differentiate the first term, this, which should give us 2n to the power of 2n times x to the power of n minus 1, and we differentiate the second term, which is 4n to the power of x n minus 1. So yeah, so if we're adding two functions, many functions are there, x squared plus 3x, suppose there's a function like this, so we differentiate this term and differentiate this term. We just differentiate separately and add them together. It's that simple actually. It's yeah. So we've covered how to differentiate these three. We're missing one key ingredient though, differentiating trigonometric functions. So yeah, we need to start differentiating that, because trigonometric functions are really important, and I think differentiating is applied mostly on those kind of functions. So start with that first, and this will also be easy because now you must have thought that, oh, differentiation isn't hard, it's easy peasy, because all you need to know is a bunch of formulae and just do a lot of practice and you'll get there in no time. So differentiating sine x, cos x, and tan x. So memorizing these formulas, derivative of sine x, derivative of cos x, and the derivative of tan x should give you the following. So derivative of cos x, the color please, derivative of sine x, so sine x should give you cos x, derivative of cos x should give you negative sine x, and the derivative of tan x will give you sec squared x. Okay, you must know what, of course, these values, what sine cos tan is. And I'm assuming you do know. Again, it's another prerequisite. This is high school math after all. So now we've learned to differentiate these kind of functions as well, and it's easy to differentiate functions like, suppose, sine 2x. So differentiating this function should be easy. So sine 2x, so let's just write the general formula first. So sine of ax plus b, ax plus b is another function, dy over dx of sine ax plus b will give you a cos ax plus b. Sine 2x should give you 2 cos 2x using this formula, and it applies for all the formulas over here. So if you want to differentiate this, derivative of this will also be a negative a sine ax plus b. Derivative of this will be a sec squared x of ax plus b. Yeah, it's just going to be like this. So it's really easy. You just use this formula. So any example you get, cos x, or let's see, cos of 2x minus pi over 3. If this is the, we want to differentiate this, the derivative of this would be negative 2, a is 2 over here, sine of 2x minus pi over 3. And same goes for here, for tan. So that's differentiating trigonometric functions. So by now, you should really know how to differentiate. Like, differentiation should be engraved into your head. After all, you've learned from such a great teacher, and you've learned all the techniques of differentiation required. This is still basic though. It's not the whole story. Math is never complete. Keep learning it till, I don't know, till you cannot take it anymore. So e to the x to the power of n, trig functions, sine x, etc., natural log of x. Missing out on anything? No. Yeah. So you can differentiate these functions by now. And now that you know how to differentiate these functions, if you have learned differentiation, so you've learned the basics, and by now, if you've listened to everything, I recommend you go back to your study table and start doing those questions of differentiation, because now you'll only get better. You keep practicing, you'll get better at it. And with using the concepts learned from this video, you are not going to fail. Forget failing, you will pass with flying colors. So if you're striving to get that 100% or A star in IGCSE, you will get it now. So you can always thank me later. And if you have any more questions, you just put them down on the comments section below. Any questions, and I'll answer them because I have nothing else to do. So thank you for watching. Bye.